Hello, welcome to Sean Builds a Lisp. My name is Sean and I am building a Lisp. So last time I had this crazy idea on how we could structure our AST. Basically the concept was that as we expanded our S expressions, we would essentially assign them classes that subclassed array. And based on those classes, we could compile those S expressions into different Babel AST nodes. Ran into some problems when I started trying to build quote, and that is because if originally I was going to, sorry, I'm scrolling around, I'm looking for call expression. Originally, my plan was to modify our reader such that when we read in an S expression, we would actually read in a call expression object. And that way, right away, we would have our compiler for that. The problem is, if you quote something, then we need to stop any macro expansion and return that AST tree. And the problem is, if you're compiling, we need, if we were to have S expressions be this call expression class, the target JavaScript file that we're compiling would need to have access to this class, and I don't really want to have to inject a bunch of runtime stuff into compiled JavaScript. So basically, we would try to compile like, I'm just going to go ahead and type into this comment here where I've already got some examples that I've been doing. So if we were to do like quote get foo b, we want this to expand into our AST tree, which would essentially try to call new expression with the arguments. And the problem is call expression class won't be defined in the JavaScript that we're compiling. It's only defined in the compiler itself. So I thought I was really stuck. I've been thinking about it a bit. I think we can kind of save this. It won't be nearly as pretty. But what I'm thinking now is that we will represent our AST only with built-in JavaScript classes and objects. And so when we go to expand that AST is when we will generate these actual classes. So basically, this would be parsed into array, and let's just do this. Array quote, and then another array, and that would be get foo and quote b. And so let's just go ahead. So these would all be symbols. And so these are just the normal JavaScript classes. So normal JavaScript array, normal JavaScript symbol. Sorry, I'm just gonna, for completion, continue and type all these out. Okay, so this is what our reader will spit out. And here I'm just gonna kind of use some kind of notation like this. Okay, so this is the source text, and the reader will essentially expand this into this array. And then when we go to expand, our expansion function will see that this is an array, and it will look at the first element in that array and convert it into an identifier. Now this is the identifier class, and this has a compile function that will compile to a Babel identifier. So we could just copy this and paste it down here. Okay, so now we have our identifier. The expander will then look up. Oops, I guess I didn't actually copy it. One moment. Okay, so the expander will then look up that quote identifier, and it will find our macro function, and then it will return. It will simply just return this array. Okay, so now when we go to convert this to JavaScript, we will turn this into, we'll object assign our array. And this will be like form.map compile, and we'll attach source location and any scopes or whatnot. And then inside the mapping, we are mapping over each element, which is compile. And so now we will have object.assign symbol for get, and we'll have our location, etc., and down the line. So basically, a quote will return its object, and our AST nodes will compile into JavaScript that, once evaluated, will return the same AST. Now, in contrast, when this isn't quoted, we will get a similar effect. So basically, when this isn't quoted, like this, we will expand this to... All right, just going to, okay. So first we read it, and we will read it into this form. Then exactly the same way, we will look up the symbol get, and that will be a function. And that function will be our macro. So this will take our form, and it will return new call expression, new member expression with the contents. And so basically, because we're actually going to compile this part to JavaScript, we will promote it to the class. And so basically we have arrays, symbols, strings, numbers, booleans, null, undefined, and objects. Objects won't quite work with this scheme, so I'm not sure if we'll be able to have like first class object literals like Clojure does. We might have to do something else, and we certainly can't have lists and arrays. We can only work with arrays. So anyway, let's get started and see if we can save this. So what we're going to do first is take a look at where we were yesterday. So we've got a bunch of this stuff. For now, I'm just going to get rid of all this. We're just going to return our form, and I think we can keep compile as form.compile. So first, let's, I don't think we need this class anymore. Fingers crossed that this actually works. I'm not certain at all. All right, so I'm going to go through here, and we're going to make our new AST. We're going to start symbol again. So let's just do symbol for get. All right, so again, what we're going to compile here is get console log, and then that will give us the console.log function, and we will pass it the string foo. Actually, let's continue. Let's do hello world, because that's just a classic thing to do. And we want this to compile to hello console.log hello world. Okay, so we have an inner array here. And okay, console log. Oops. Close that. And this is actually going to be a symbol for quote. And we need to close that array, and then let's just stick with primitives for now. Okay, that looks right. Yep. Okay, so basically this is a simplified version of what our reader is going to spit out. Our reader will actually return these as objects and attach source location and whatnot to it. Okie doke. What's next? Let's just stop here at expanded because we're gonna crash when we go to compile it. All right, so just running this in the debugger, and we'll pause and not be able to continue because we have a bunch of other stuff that's broken. Where are we? Where are we trying to compile? Okay, I think we messed up our breakpoint as well. Let's just rerun that. Okay, step over, and we're gonna log out our expanded, which so far is just exactly our form. So here's what we'll do. If we can find our expand function here. All right, so if form.compile, that means we've already expanded it, so we can simply return the form. If it is an array, then we want to expand it. So first thing we will do is we will get the first item. So we will expand the expand form 0. Okay, so if we get a function, that means that we're dealing with a macro. So we're going to check that the type is a function, and if so, we will return expand calling our function with our new form. Okay, so first, and then form.slice1, and that's it. Oh, you know what? We need to resolve it. All right, so macro equals resolve form env. And then we want to call the macro function if it's a function. Otherwise, we're going to assume that we have a call expression. So we'll return new call expression with first and the rest of our form. Slice 1, and we need to expand each of those forms. So we will expand the subform in our env. All right, so otherwise we have some other type of primitive. I'm going to ignore objects for now and just deal with symbols and strings because that's the example we are trying to compile. So we will also have to check for null. So if form is equal to null, then we want to return t.null literal. Oh, wait a second, that's not right. We want to just return the form for now. We'll probably want to do something a little smarter. Okay, so now that we know that it's not null, then I guess we can still have undefined. Yeah, so let's just do equals null. All right, so basically if it's null or undefined, we'll just return it and deal with it in the compile step. So we want to switch on type of form.value of. And so basically what this is going to do is we might have like a string class or maybe a symbol class rather than an actual symbol. So we're going to just reach into value of, and if it is a primitive like a real string, then value of will still return the right thing. So if we have a string, and I'm not going to worry about source location or any metadata right now either. I just kind of want to get this into a working state where I think we could plausibly continue. Okay, so if we have a string, then we're going to return our string literal class and value of, and case symbol. We will return new identifier, and I think what we need to do is go look up the symbol the way that our identifier is set up right now, and this is totally subject to change. Okay, so basically now we should be able to expand our macro, which is get, which should expand into member expression class. Which will then be called with call expression. So one thing we need to do is, so our quote is simply going to return form1. I think we need a special case quote actually. I think what we need to do here is okay, so because so basically what will happen here is if quote's just a normal macro, we'll call it and then we'll immediately call expand, and so it'll be as if it never existed. So what we need to do is say if first, I'm gonna write a little helper function. Function is symbol. And so basically if this is either an instance of the symbol class or a primitive symbol, we want to return true. So form is an instance of symbol, or type of form is equal to symbol. All right, so if is symbol and first dot value of is equal to symbol for quote, then we're just gonna return form1 and do nothing. And now we're done. Okay, I think that will work. Cool. So, one thing we need to do is in our env, we don't have array literals anymore, so we need to interrogate our form. Okay, so we're going to grab the property by expanding form 2. So remember, this is get object property. And so if this is quoted, sorry, we want to do this up here. Okay, let's just delete all this and delete that. Okay, so property, we will expand form 2 in our env, and then we will return a new member expression. We'll just return form 0 as is for now. I'm not sure if we want to compile this or not. We'll see. Okay, so that says farm, not form. That's going to be a problem. Okay, so we will expand form 1 in our env. And then Oh, actually, this will be at the compile stage. So this is really just new member expression, and we can just do form, and we could just map the expand. All right, and so we're gonna expand subform and env, and that's it. Actually, really easy. And comma, and then we can simplify that expression too. Okay, so really simple, and then basically our member expression compiler will be different. So this is kind of where it's a little wonky. All right, so all right, so if is symbol this too, and so this is totally the opposite of what I was doing yesterday. Otherwise, we will just call a compile on that. So if it is a symbol, then all right, we can all right, just thinking how I want to do this. All right, so this, I'm not happy with this again. We'll see how this goes though. Let's see, symbol for, or key for, value of. Okay. Actually, let's just do t.identifier right away. Why not? Okay, so basically, let's see how this goes. And we'll rerun. And I want my breakpoint there. Bummer. Okay, where's this? All right, let's see. What is ID? ID is this guy. Okay, so I'm gonna make my resolve function a little smarter. All right, so if ID instance of symbol, then we'll resolve symbol with id.value of and our env. If our type of ID is equal to symbol, and then we will return env ID, otherwise we'll return undefined. Okay, and my breakpoint got moved around again. We want to break there. Okay, let's take a look at expressions. So we have call expression, identifier. Oh, we didn't do it. We did not expand our macro. And let's see, why did we not expand our macro? Oh, we want to resolve first, not the entire form. Let's try that again. Okay, let's interrogate this guy, and again, we did not expand it. Okay. All right, well, let's put a breakpoint here and just see what the crap is happening then. Alrighty, rerun. Okay, first is identifier get. Oh, because we're expanding it. Okay, so we want identifiers to, actually, you know what? I think that we can just call value of, right? I mean, if we have anything that gives us a symbol, I mean, that's a totally valid thing to look up. All right, let's try this again then. Okay, it looks like we're probably forgetting to pass end someplace. There it is. Oops, end. All right, shall we rerun? Just realizing it's a little dark in here, I might pop the light on. Okay, so we still have no end. Is this another one? Okay, at least we're, oh, okay, so first of all, we need to call our macro with our end, and then when that comes back, we need to expand with our end as well. All right, where are we here? Subform. All right, where are we here? This is ID is undefined. What's form? Okay. All right, so form 0. Okay, so basically, for some reason, the first element in our array, we are successfully creating an identifier, but it looks like we're not actually setting the key of the identifier. Let's take a look at Identifier Constructor. Okay, that looks correct. Here we are. So let's see. Our first element is that symbol key for that is undefined. All right, so I'm just poking around to see why that's undefined. And now key for form 0 dot value up. Okay, how did we make this thing? Oh, that's why. Symbol for console. Okay, let's rerun that. Okay, let's inspect. All right, step over this guy. Let's see. Member expression. There we go. And bummer. Wait a second. Call expression. Identifier is console. Okay, something has gone terribly wrong. Okay, so we have a call expression where the first, where the object is a member expression. 0 is get. Somehow. Okay. Somehow we messed this up. Let's see. All right, so it could be in our env. Okay. I'm just gonna put a breakpoint here and rerun, and let's see. Okay. Form. We have an identifier, which is get. Oh. Is my actual AST incorrect? No. I think it's expanding. When we expand the call expression, the default call expression, sorry, looking for my expand function. Expand, there it is. Whoa. And, okay. Where did we go here? Expand. Okay. Oh, there should be a ... Okay. We were making our macro expansion form incorrectly. Okay, let's step over and take a look at this. Okay, so we ended up expanding past our symbol. Okay, let's see here. I'm gonna put it. So basically, we had a quote, and so we're quoting a symbol, so we should get a symbol back out, but we got an identifier, so I'm just gonna put a breakpoint and see why that is. Okay, I'm gonna put a breakpoint where we have our macro call, and because we never even got to this quote. Okay, let's take a look at our form here. So this is our get. I'm gonna just expand this form inline here and see if what we get. Get an identifier is symbol. All right, so I'm gonna check to see that that thing is actually a symbol. Yes. All right, so if we expand it, I see. Okay. So if we expand that, then we're going to get an identifier. There we go. Let's just try that. Not super happy with how this is going, honestly. Okay, this time we have our symbol, so we should be able to compile it. Let's take a look at the compiled. So we have a call expression. Callee is a member expression. Arguments is a string literal, so we should be able to generate it. And let's see what we generated. Console.log foo, great, and we will log out foo. But we wanted that to be hello world. Okay, so I think what I'm gonna try doing here is I'm going to expand a quoted form of this whole thing. And make sure, so basically with this, we should essentially get out the original form. Okay, let's see here, form. Oh, you know what? We won't always have compile. So this will be if form. If our form has a compile function, then we will simply call it. Otherwise, if it's an array, we need to return t.array expression, and we will just map the form with compile. Syntax error. Okay, cool. Else if form is null, we will return t.null literal. Form is equal to undefined. We will return, I think we need an identifier for this one. Okay, and then we'll switch on form.valueOf. We are conveniently going to ignore objects right now. So we'll just check for strings and symbols. If it's a string, then we'll return string literal. And if it's a symbol, we'll return an identifier. Wait, no. We need to, all right, so if this is, we need to do object assign on these guys. So this will be key, well, call expression and member expression. So we're looking for object assigned. And so that will be object. And so basically what this is going to do is it's just going to kind of bump any of the primitives into an object that we can basically use as an AST. Okay, I think that's right. Okay, symbol's gonna be we need a colon there. Great. Okay, symbol's gonna be a little more complicated because there's no symbol literal. So so this will be another call expression. And this will be another member expression, and this will be the identifier symbol, and then we need identifier for, and this arguments. Oops. Okay, so that's our member expression. We'll close that, and then we have to close call expression. This will be symbol.key4. Okay, let's run it and see what happens here. Okay, let's expand it and crash. Where are we here? Okay, what are we trying to build? Let's see, array expression and args. Undefined, undefined. Okay, that's a problem. Let's see, form. What if we try to compile form 0? We get undefined. Okay. So we've got to go find our compile function. Breakpoint. Okay. So what do we have here? We have form. Compile form 0. What do we get? Okay, let's continue. Okay, so now we're in an array. So we should get the same thing. Now we're a symbol. Not an array. Not null, not undefined. Did we forget? Let's see here. Form.value of symbol key4 form.value of. So I'm just manually checking what's going on here. Here it is. I want to switch on the type of the value, not the value itself. And we'll rerun. Okay, let's see here. Can we compile this thing? All right. Let's just step out and see. Still crash. We're still getting undefined, huh? Okay. Oh, at least it's in the call expression this time. Okay. Something totally wonky happened here. Okay, so we get an array with a bunch of nested arrays. Somehow what is happening? Why are we here? Okay. I'm gonna rerun and oh, did I? Okay, so we're just gonna step into this function again. Okay. So let's see. Let's just call compile on this manually. Huh. Let's see. Somehow, wait a second. We just called compile on a string and got a call expression somehow. Let's see, type of form1. Type of form1 dot value of should be a string. Okay. Okay, we're just gonna keep going here and see why that happened. Okay, so now we're compiling the array. So we'll get array expression, and then we'll loop through each symbol. So this should jump into the type of, and we should jump down to symbol. Oh, right. Okay. So it was correct. Okay, so let's see. All right, value. Okay, call expression with args. So our first one is a member expression with a symbol for. Cool. And our second one is just the string get. Okay, I'm just gonna pop out and what's the error message? Huh. Let's see. Val. Okay, I don't understand why it got it's saying that it got undefined here. Val is definitely a string. Okay. It probably called type on it. Okay, so for some reason we're putting this together wrong. Okay. Symbol for key, string literal. Oh, this needs to be a string literal as well. Okay, let's try that again. Let's disable the breakpoint. Very confident. Okay. All right, let's see here. So we have our compiled, and let's take a look at the generated. All right, so we've got a bunch of arrays and object assign, and if we eval it, not really. Okay. Okay, so okay, it's just not printing it. So what I'm going to do here is the whole point of doing this is to make sure that we can handle quoted forms correctly. And so that being, we will essentially, we'll compile a function. That function is returning a quoted form because it's a macro. And then we need to be able to take that quoted form and then compile it again. So that's what I'm going to do. So I'm going to get quoted out of here. And then we're just going to go ahead and do the whole song and dance again by hand. So let's just do q expanded equals expand quoted in our env, and then q compiled equals compile q expanded. And let's just log these out. And q generated is going to be generate q compiled. Let's log that out. Generated. Let's just q generated. And then let's go ahead and eval it. Let's see. All right. Here we go. Oops. Let's call this q form then. I have another constant variable called q form, so I can't reassign it. That's all. Okay. Forgot to log. Let's just make sure our q form is our array. Yep. And so this should be pretty much just this inner. I mean, it should be form. So. Okay, we don't need that. Let's just step out. All right. Compiled. So far, so good. Generated. That looks like the thing. And then we eval it. Did we eval it? Did it print? All right, let's try this again. I'm just going to run this from node. Oh, it's q generated dot code. Okay. Okay, so this does work, albeit a little crazy, huh? Okay, so, but everything does actually work correctly. The only question now is if we're happy enough to go refactor everything to use this new scheme. Heck, you know what? Let's go for it. All right, so what do we need to do? Okay, so this compile function is kind of gonna stay here. Okay, so first things first, let's go to our reader function. All right, read.j. Oh my goodness. VS Code is indexing files that no longer exist. All right, let's see. We want vlist reader, this guy. Okay, so we no longer need pretty much any of this. So I think most of our reader is gonna stay the same. The thing that's gonna change is this guy. So let me bring this over here. All right, so here we go. If we actually pretty much all this reader is going to do is return object.assign our value and ops. So ops is going to be locations and stuff. And again, so this this scheme is not going to work for objects. We might not really be able to have object literals that are like first class at compile time. We can certainly have object literal syntax that compiles into an object, but we'll see. I think I'd like to just kind of get everything bootstrapped with what we have now, and then we can see if we can do something with objects. Or we could say that compile time objects just lose their quoted properties. I'm not sure. We'll think about it. Okay, so basically what I want to do here is I just want to attach get started prepared for source map, so I'm going to attach location metadata. So I'm going to jump over to my input stream class, and we're going to modify this a little bit. All right, so so what we're going to do, the line will start at 1. And this dot column will start at 0. And so we're just going to watch the characters that we're reading out of the stream and keep track of the line and column here. I don't know if this is going to be the permanent way to do this, but it'll work for now. So we can modify this. We just need to spy on it real fast. All right, so if char is equal to new line, then this dot line is ++ and this dot column equals 0. Otherwise, this dot column ++. Okay, so now we'll just keep track of line position and all that good stuff, and then we can attach that here. Whoops. Okay, so we need to just fix this up a bit. Okay, so we want trivia end line equals stream.line, and then trivia end column equals stream.column. And so now we can go make a source location. So we're going to pass in. And so the format of this, I'm just going to follow the Babel syntax so that we can just like pass it right along. So start line will be trivia. Whoa, where did my cursor go? trivia end line, and column will be, of course, trivia end column. Alrighty, and then we want to do the same thing for end, but we will just use the line and column immediately from the stream. Okay, cool. So now basically our reader is now returning our kind of raw primitive objects here. Oops, this should be end, and then I'm just gonna go ahead and throw trivia on here, because why not? Trivia. And so we need to track the position. Okay. Trivia. I'm gonna make this just a little easier to, yeah. What if we called this start line? Then we can do, so now we need to go change this. A little just easier to, okay, so. Trivia line is going to be stream.line, and trivia column will be stream.column. And then we can just go ahead and attach that to our metadata as well. Okay, so now we can track where the white space at the beginning of a form is and all that good stuff. And we are no longer reliant on Babel at the reader level, so that's also a good thing. So now all of our tests are going to be broken, aren't they? Actually, maybe not. Let's see. They will be. They will be broken for sure, so let's just run them. That's interesting. I wonder if that's, let's go take a look. All right, so what we want is syntax.spec. All right, so we have, whoops, npm test 1, and we want to test syntax.spec.js. Does that work? Yep, I need a dash dash. Okay, so I don't know if this is going to work quite the way I expect or not. Oh, this should be symbol for foo. Run again. Okay, still failing. Let's just check the value of, I guess. Okay. So this should essentially be equal to new string foo. Let's and then this would be new number 0. Oh. Okay, so I just passed this. We want to call value of on the syntax object, not the symbol. There we go. Okay. Let's see what else is broken. Probably a heck of a lot. Okay. All right, let's fix read list next. Okay, let's open up that file. Ooh. Okay, so this is a bit of a problem here. Wrapping our symbols up in objects is apparently not testable. Okay, so what I'm gonna do here is I'm just gonna add another random test. And let's try expect object dot assign symbol for foo to equal itself essentially. Let's see. And I'm just gonna throw an only on there so that that's the only thing that runs, and let's try running that again. Okay, I'm gonna put a breakpoint and just jump in and debug this. We'll see, maybe Chai's doing something that we can fiddle around with. Okay, if we can get something that compiles. Oh, there's a random E there. Oops. Yeah. Okay. How about that? Let's try that again. No, not syntax. I won't read list. Okay. Are you running? You're trying to run. Okay. Okay, so I'm going to step in, and so now we're creating the expect function. So probably, here we go. I think we want to be here. All right, I'm a little lost. Okay. We step out. Shoot. All right. Let's see where this assertion is thrown then. Put a breakpoint there. Maybe we can. Okay. So it looks like this is the start of the test, and so what we're doing here, just kind of remind ourselves, is we want to be able to essentially deep equal on symbol objects. Okay. Okay, let's step in here. Wow, what's happening? It's crazy. Okay, let's just keep stepping in. Just reading this comment that's above this line here. Okay. Some proxy nonsense. I also considered using proxies for the AST, but just kind of figured it would be too slow. Okay, so I think we're already too far. All right, so by the time this even gets called, we've already failed the test. I'm gonna rerun and see if before this util.test function gets called, if arguments is already the failure. Yep. Okay. So let's just walk up the stack trace and see. Ah, here we go. Alright, maybe don't need that breakpoint anymore. Alright, so I'm gonna step into this guy. Here we go. Where are we? I'm just gonna keep stepping. Like in a maze, if you always keep your hand on the wall. Right, it seems like we've been here before. Oh, okay. All right. Left hand, this looks like it. Okay, simple equal. Compare them by reference. Okay. All right, just reading the comment. Anything that is not an object, symbols, functions, booleans, numbers, can be compared by reference. But these should be objects. Okay, so let's step in. And this should return false. Okay. Then we're just going to step into the right one so that we don't lose our place. Okay, so now this function is returning null. Whatever that means. Okay, so simple result is not equal to null. Okay, we have no simple result, so we have to do deep equal, which we expect. Memoize compare. Okay, so basically this should just return null right away because we've never called this function before. So okay. Okay, I can't memoize primitives. That makes sense. So we're gonna get the left-hand map, and okay, no memoized result. And so, all right, looks like we're gonna do the same song and dance for the right-hand side. And we have no memoized result, so we should continue to actually compare. All right. Okay, what are we doing here? What's string tag? Okay, that makes sense. All right, what do we do with that? All right, looks like we're gonna find out that the right-hand side is also has a string tag symbol. Okay, and we're going to set our we're gonna memoize something here. Whew. Who knew building a Lisp would be entailed debugging? Try. Okay, memoize those results, and then extensive deep equal. All right. Oh, son of a gun. Okay, so basically I feel like symbols should be up here. What if I do that? I'm gonna rerun. Okay. So, if I can find where I was here. Test. All right, let's see here. A bunch of open files. Is it this? No. Insertion. All right, so it's this guy. So what I did here is I noticed, so if I'll just, whoa. Okay, VS Code is going a little crazy. What just happened? Where were we? What did I just do? Okay, here we go. So basically, the way the try seems to work is it checks what type. If it's an object, it checks to see if it can determine what type it is. And for these cases, string, number, boolean, and date, it compares the value of. And so that's the value that those classes are wrapping. And then for promise, symbol, function, weak map, weak set, and error, they do a strict equality comparison, presumably because value of for those classes doesn't make any sense whatsoever, except that value of symbol does make sense, so I moved it up here so that we would compare the wrapped symbol. And so then at that point we'll go in and it will probably see that they're of type symbol and compare them directly. I'm gonna pop over to GitHub and see if they have any issues open on that. Right. They have no issues. Is that because they closed them? Oh well. Okay, we're looking for, let's try searching for symbol value of. Okay. All right, so I'm just reading through to see if there's somebody else that came to something slightly similar. So just kind of reading through. Okay. So there's something about symbols. I'm just going to check the diff and see if there's anything interesting for me. Type of symbol. Okay, I wonder if I could just use should. Okay, what do we have here? Looks like this is only for direct comparisons of symbols, not necessarily a deep equal. All right, I'm just going to, I don't know what I'm going to do. I'm just going to keep fixing my tests, even though this is going to be fraught with problems. All right, so if we jump back to read list, I'm going to get rid of this and just gonna rerun those tests. So since we're calling syntax, everything should still be fine on the reader tests. Okay, so this was attaching source code information. That's a problem. Okay, let's just go for it. Oh, that's a lot of crap to put on though. All right, so someplace I have like an excluding thing. All right, whatever. Let's just do it for real. All right, trivia, sorry. Trivia will be okay. So this will be line 1, column 0. Start will also be line 1, column 0. And then end will be line 1, column 3. Come on. Oh, lost my 3. There we go. Alrighty, reset that. This is going to be annoying if I decide to change this again. Okay. Actually, this will be column 1, won't it? 1, 2, 1, 1, 4. Okay. Let's just copy paste that everywhere. All right, so 0, 1, 2, 3, 4. So trivia will start on 4. Nope. Okay, this is for the array actually. Okay, this is the array syntax, and just paste that again. So this trivia will be start on column 4. The actual thing will start on column 5. Right, 0, 1, 2, 3, 4. So here's 5. So then bar will be 6, 7, 8, 9. 7 to 9. Okay, so then 9 is here. So Baz, this is so annoying. We'll start on column 9, trivia, we'll bump it to column 10, and then 3 characters. So that's 13. So that's 9, 10, 11, 12, 13. And so our list will also end on 13. All right. Fingers crossed. Okay. So this guy will be pretty similar. Oops. Let's just copy this object here. What if I make a location? I'm just going to make a location helper. All right, index.js. global.look equals. All right, so trivia, we're just gonna assume a line of 1, and so we just want to pass this trivia start and end columns. Trivia start end, so then we can then return delay. Yep. Okay. Trivia line 1 column trivia, and start will be line 1 and column start. And let's just search and replace start to end there, just to make things a little simpler. Right, so basically now we can do location will be 1, 1, 4, and this guy will be and then location will trivial will start on 4, then we'll start on 5 and move 3, so that's 8. And let's just see here. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. All right, I'm going to run these tests and then clean up the other test. Great. A lot more readable, huh? Seven, 9. 9, 10, and 13. And 4, 5, and 13. Okay, and just rerun that test just to make sure I didn't typo anything. Great. All right, on to the next test. Probably a lot of things broken. Okay, well, we know expand is broken. Let's just only test our read. Oops. Let's just test our reader functions here. We need to totally rewrite expand anyway. I mean, we essentially did. Oh my gosh. Our reader functions are all good. We're done. Okay. All right. Okay, let's run test again. Actually, let's just test expander. Okay. So what we want to do here is I'm gonna close out all these files, start fresh. Okay, so I'm gonna open up my compile.js and my expand.js. So basically we wrote our expand function over here. So this is pretty close here. I think we're gonna look at this. We can get rid of all of this crap. Okay, module.exports equals expand. All right, so I think what I would like to do here is to abstract away these classes. So, I mean, for the foreseeable future, we are going to be working with the Babel AST, and I think that might even be true for the duration of this project. However, it'd be great if we didn't have to pull in this as a dependency at this point. So let's go ahead and let's make an env. I'm gonna make env a class, I think. So class env. Alrighty, so all right, string, symbol, number, Boolean. What else do we have? Null. Array. Oh, we can't call that null. If we have it, it'll be an object. All right. Primitive expansions. Okay. So then we'll have a resolve function that takes a form. All right, let's just set up this dot macros, and we'll just make that an empty object for now. Okay, so if we jump back to our compile function, we basically want this resolve. What is this? Okay. If form and type of form dot value of is equal to symbol, then we will return this dot macros and form dot value of otherwise. We're going to return undefined for now. Okay. Whatever. I'm just going to make up some stuff here. Oops. Okay, so let's so what do we want to do here? All right, so if form is strictly equal to null, then we'll return this dot primitive expansions, and we'll pass it with form and env. If form is strictly equal to, oops, sorry, dot null. Undefined. Actually, yeah, that's right. Primitive expansions. Dot undefined form env. Okay, so otherwise, if form is an array, all right, so we can see that this is looking pretty similar to this, right? Should be array. Turn this dot primitive expansions dot array form env. Otherwise, we can just call type of form dot value of and call that with the form and the env. And so basically, what we're doing here is basically pulling out these class constructors into, and we're gonna dependency inject them through the env. So when you boot up the compiler initially, you're going to import the ES5 environment and invoke the compiler with that. And that ES5 compiler knows that it's going to Babel, so it'll include these classes, and we'll be able to pass this through the env. All right, so basically, as we resolve, so this macro expansion piece will stay the same, and that's the expands business. Cool. So I think we have a resolve function, and so okay, whatever. We're going to just get rid of this. All right, well, so env is an object, so we're just gonna make this return resolve. I'm just gonna defer this. This is a very simple wrapper. And eventually we're gonna come back and add scopes in for hygienic macros, we think and hope. The same problem that I ran into yesterday might cause a problem for that as well. Though I'm not really all that convinced on hygienic macros. So all we have to do here is okay, I'm just gonna call it on the array itself for now. I think that's not what we actually want to have happen, but we'll say env dot expand primitive, and we'll pass it first and dot 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 form dot slice 1. Okay. Oh hey. Okay, and then all we have to do is call env dot expand primitive, and we can just pass it to form. Okay, so we need to, let's take a look at our expand tests now. So we'll have to make an expansion environment for this guy. And what do we want to do? Maybe we just want to trash these tests altogether. Yep, I'm just gonna do that. And at this point, we don't want anything to do with Babel. Okay, so what do we need here? We need to get env. We just need to set up an env. All right, so what do we need? We need a string is going to be a string. All right, so if it's an instance of string, then actually, you know what? Yeah. What do I want to do here? I'm not really sure. Whatever. Okay, maybe we've been going for a little bit. I feel like I'm ready for a break, and this is probably as good a time as any to stop, because otherwise I'm going to get really in the weeds here. All right, so I'm going to put a to-do in here. So let's flesh out, expand functions or tests. Not sure what we want that to look like yet. So what I'm gonna do over here on ES5 is just gonna delete everything. We're starting fresh. Okay, expand.spec, so there's no more ES5. Printer is no longer valid. All right, you know what? I'm just gonna kind of stop here, and we'll just come clean this up another time. All right, what do we have? Git add, only one file to add today. Refactor reader, new primitives. Together just trying to figure out what I should message in my commit here. And compile. And we'll push that up. And we are in a branch right now. So we'll clean this up and then merge it in, and then hopefully have a programming language. Anyway, okay, I'm going to call it quits from here. As always, thanks for watching, and until next time.